How does the second law of thermodynamics prevent perpetual motion? Imagine a machine that runs forever without needing any fuel or energy input. It sounds like a science fiction dream, right? Well, the second law of thermodynamics is the reason such machines can't exist. This law says that in any closed system, disorder or entropy always increases over time. Think of entropy as chaos or randomness. When energy moves around, it naturally spreads out and becomes less useful. If you try to build a perpetual motion machine, it would have to keep working forever without losing energy. But every real machine has moving parts like gears, pistons, or wheels. These parts rub against each other or face air resistance, which creates heat. That heat is energy that escapes the system, making the machine less efficient. Even in a vacuum, tiny molecular collisions still cause energy loss. The second law divides these impossible machines into different types. Machines of the first kind would create energy from nothing, breaking the law of conservation of energy. Machines of the second kind would convert heat into work with perfect efficiency, which is impossible because some energy always disperses as heat. Machines of the third kind would eliminate all friction and resistance, but doing so would requiring energy that outweighs any gains. Think of Maxwell's demon, a thought experiment where a tiny being sorts molecules to create a temperature difference without work. It seems to violate the second law, but the demon needs energy to see and sort the molecules. That energy cost cancels out any advantage, keeping the law intact. Throughout history, inventors have tried to beat these rules. Some built water wheels that they claimed could run forever, but they always needed more energy to pump the water back up. Others created chemical devices hoping for endless motion, but they failed because energy always leaks away. Even with superconductors that have no electrical resistance at very low temperatures, maintaining those temperatures costs more energy than the system produces. In the quantum world, some strange phenomena like time crystals show atoms moving in repetitive patterns forever. But these do not violate thermodynamics because they cannot produce usable energy. They just move in a way that doesn't break the rules. The bottom line is this: the second law of thermodynamics is woven into how the universe works. Energy naturally spreads out, and disorder always increases. These rules are not just technicalities, they are fundamental features of reality. No matter how clever the design, perpetual motion remains impossible because of these universal laws.